Today we're going to be talking about network performance monitoring and diagnostics. A modern NPMD requires views into many different parts of the environment. So for example, applications, protocols, device health, virtual environments, whether it's an OpenStack private cloud or whether it might be a Cisco ACI software-defined data center, virtual machines, NFVs, to name a few. In order to effectively monitor these environments, we need a very scalable, flexible architecture. And today I'm going to be showing you CA performance management and several of the data sources that cover those types of environments. What's very important too is that I'm able to create a role-based dashboard with very rich visualizations for each type of user. So for example, what an operator uses might be very different from what an engineer uses, but the tool has all of that data and we can provide a visualization that's appropriate for each of the roles. So let's take a look at what we have here. At the very top, I'm looking at the applications in the environment. And this view might be something that's very applicable to an operator role. See a bunch of tiles that are color-coded that tell me how well or how poorly an application is performing. I also see at the bottom of each of the tiles that there's an area for network, server, or application. So what we're trying to do is to narrow the problem domain for that particular application if it's performing poorly. Is it what we think is a network issue? Is it what we think is a server issue? Or is it what we think is an application issue? And the way we're able to determine that is that we're watching all of the packets flow through the network, and we can measure things like server response time or network round trip time and dozens of other metrics. And we put these into categories that indicate whether they are a network issue or a server issue or perhaps an application issue. So at a very high level, again, at an operator level, we're able to see, hey, there might be some problems with one of these applications. One of the other nice things that we can do, because we're watching the flow of all the packets, is to provide a visualization of what that application looks like. So let's take a look at that. I'm going to click here on this application, and it's going to automatically build out the flow of the packets through this application, because again, we're watching them go across the wire. And I can see each of the tiers inside of this 4-tier application and how they're communicating to each other. Another way that we can look at this data is to look at it in these bar charts down here. So I can look at the performance by application. I can look at the performance by server. I can look at the performance by network. And what I'm trying to do here is look at these time-aligned graphs and try to visually correlate when there's an issue. So for example, if I see some orange here, which indicates a major issue with one of these applications, I can come down and see if that's happening at the same time across all of my networks or all of my servers. And I see, for example, that it's only happening in my Michigan site. It's not happening in Florida or Arizona. So right away, I've been able to use this tool to look at how the application is constructed. I've been able to look at when the degradation occurred, for how long it occurred, and who it was affecting. Let's go down a little bit further in this particular dashboard. And I'm looking at a weather map. And a weather map is simply a geographical representation of data regarding the network. And what I mean by that is I'm looking at each of the links here in the wide area network, and you can see that one of them is fatter than the other, which is fatter than another one. So these links are actually dynamic. They grow and they shrink based on the amount of bandwidth utilization occurring on that particular link. In addition to that, I'm also able to color code the sites based on CPU and memory utilization of the devices at that particular site. So I can immediately see here inside the Michigan site that I have devices that have exceeded my threshold for CPU utilization. I'm also able to see that information in a tabular format over here. But again, from an operations perspective, it's very easy to quickly look up at a map like this and see where there might be an issue within the environment. Again, I'm using many different types of data to present these visualizations. So for example, SNMP data, I'm looking at packet data, I'm looking at flow data. The next step here is to drill down into that Michigan site to see where the problem is. Now that I've determined that the problem is in our Michigan site, I can dig down deeper. So by clicking on the weather map on the Michigan site, I am now brought to a page that is all about the Michigan site. And what I'm looking at here is a very high-level detail. Again, something that maybe an operator would go to as a first level of triage to understand what's going on. So for example, my router here, is it available? How long has it been available for? And then I can look at things like CPU or memory utilization on the devices here, or the interface utilization on the devices here. I can also see the events that are occurring inside devices that are at the Michigan site, and I can see that there is a recurring problem that's happening. I can see that things are improved and stabilized, and then we're seeing a degradation, and they're improving and stabilizing, then we're experiencing degradation. So there's definitely something happening here. It's a recurring problem, and I can actually scope out the problem here by looking at the time frames as well. I can come down here a little bit further as well and look at other statistics. Again, these are coming from SNMP. Some of them are coming from that flow data that's available to us as well. So one of the things that I can do is dig a little bit deeper. I'll look at the network health for this particular site. And I can see that interface utilization on a percent basis is not out of the norm, so that's good. I'm also seeing an overlay here of my business hours, which is nice. It's something that you can do with a site group, so I can either set business hours or service hours for a particular site as well. What I'm also looking at down here is CPU and memory utilization, and I see the memory utilization for this particular switch happens to be at 97%. So that's what triggered that red icon on the weather map. So this is definitely something that's happening on the site that I should take a look at. So we went down and we scrolled through, we looked at the weather map and did a single click. We got to the site, did a single click, and now we found what we think the problem is in this particular site. What we can also do here, if we thought that there was an indication that there was an interface issue or a problem on the link itself, is we could go ahead and click on the link on the router here. And this takes us in context to a page that has information all about that link. So we'll get information such as bits per second, we'll get interface utilization in and out for that particular interface, we'll get discards, we'll get errors, the type of information that you would expect. And maybe not a level 1 operator, maybe this is where a level 2 operator starts to get in and start looking at things and understanding what's going on, especially as we start looking at maybe quality of service on the line, things like that. Let's take a look at the net flow. Again, part of a holistic view of your environment, or a modern network performance monitoring and diagnostic package would have this information. So whatever the flow technology is, whether it's NetFlow or IPFix or SFlow or JFlow or flow from an Open vSwitch, things like that, you need to be able to get that information in. You need to be able to decode it properly and more importantly, put it in context with everything else in the environment. What we've been looking at here are out-of-the-box dashboards but any of these views can be extracted and put into a role-specific dashboard that makes sense for a particular role, whether it's an operator or an architect or an engineer that's looking at this type of information. And we can see again flow data for this particular interface. We're looking at the different protocols that are transiting the interface. We're looking at SNMP information overlaid next to it so I can see these at the same time. And then we're looking at things like conversations, who the top talkers are, that type of information. And then finally, the last thing I'll show you in this particular dashboard is quality of service. So again, just more detailed information that we can see about a particular interface to give us more information to help us triage when things are happening. So I see my CBQoS information here on this default dashboard, and then overlaid, or not overlaid, but represented at the bottom as well are things like the type of service, classes and things like that, so I'm able to visualize those at the same time that I'm looking at my quality of service metrics. Another important feature of a modern network performance monitoring and diagnostics platform is support for new and emerging technologies. So software-defined networking is certainly something that's here. A lot of companies are taking advantage of it. There are many different aspects of software-defined networking. What we're going to look at here is an example of software-defined data center, Cisco ACI, with an OpenStack environment. And what we need to be able to do here, again, for our different roles that we are presenting information to, is to provide that information in a way that's very easily consumable by them by using rich visualizations. As you'll see here, I have the ability to look at the Cisco ACI environment. What I'm going to do is I'm going to take a look at this in this example from a network perspective. So I'm going to go ahead and expand our fabric here and our pod, and I'm going to go ahead and look at one of the leafs in our spine and leaf topology here. And what this is doing over here on the right hand side is starting to give me some visualizations that show me the relationships between things that are physical and things that are virtual. This gives me a better understanding of the environment and how these things interact with each other. So for example, this is where we started. We started at this leaf node, and then what I'm looking at down here are two different application profiles that are active on that particular leaf. So if I go ahead and click on this application profile, what it's going to do is bring up more information about that particular construct. So application profile is a virtual thing. It's not something you plug into. It's not a piece of hardware that you buy. It is a concept. And you can see on the left-hand side here, I have breadcrumbs that lead me back to the view that I was just looking at. And in addition, over here on the left-hand side, I'm also coming down the tree in the various areas that I'm looking at as well. So what I'm looking at over here in this visualization, so again, I'm looking at this particular application profile. So at the top, I see that virtual construct. And then down here at the very bottom, I'm looking at the different hardware components that that application profile can access or be accessed through. What I'm looking at here in the middle are the endpoint groups. So these are the various groups of endpoints, whether they're subnets, which some folks are doing in what's being called NCI, or whether they're actual applications or endpoints, which is what ACI is designed to do. And then in between these, what I'm looking at is the contracts. And the contracts simply specify how resources are consumed, who can talk to who between the various endpoints. So you see all of this is represented in a very easy to see manner, something that again an operations team would be able to click on and understand very quickly. And at any time I can click on the health button up here, which would take me to the ACI health scores for each of the components. So ACI does a measure of self-monitoring and assigning scores to its components, and we represent that as well. I'll show you that in a little bit here, but I just wanted to let you know that at each level of this, as I'm going through, you can click on that ACI health and it will take you to a dashboard that allows you to visualize those health scores over time. I'm going to go ahead and go into one of these endpoint groups. So I'm going to go ahead and just click on this. And again, now you'll see we're stacking kind of the history or where we were. We started at the application profile. We moved down to this endpoint group. And now I can see the actual members of the groups. And again, as always, at the very bottom, I can see the leafs, you know, how these things are accessed ultimately. So again, that visualization between the virtual construct all the way down to how do I access this on the network. And what's really great about this technology, especially if you're using OpenStack or some of the other supported VIMs that we look at, is that I can go ahead and then click on one of these endpoints and I can see from top to bottom how it's laid out. So the virtual machine that's responsible for this, for example, the OpenV switch that's doing the routing for it. So if I'm connected into my OpenStack environment and my ACI environment, I'm getting the best of both worlds. I'm able to see from the leaf all the way up to the application profile, but I'm also able to see how it's constructed inside of the private cloud, the OpenStack private cloud. So I can see the virtual machine, the hypervisor, the OVS that it's running on. All of that is available to me inside of this stack as well. So as I had mentioned earlier, we have the ability to look at the ACI health for all of the components within the ACI environment. Here's an example of that dashboard. And what we're looking at here is each of the components in here. So you can see the leaves, you can see the spines, you can see the application profiles. And we're looking at the health scores as reported to us through Cisco ACI. So the APIC keeps track of this, and it's something that we can query and give back to you. And we rank them from least healthful to most healthful, so that whenever you're looking at this dashboard, the things at the top of the list are the things that you want to concentrate on because they have the lowest scores within the environment. And we take this information and we trend it over time. And just like any other metric within performance management, we have the ability to baseline this information. We have the ability to set thresholds against this information. We have the ability to do projections against this. So what is it going to look like in 30, 60, 90 days based on the past performance of this particular metric? So these Cisco ACI health score metrics, again, just like any other metric that we ingest into the system, inherits that big data analytic capabilities. So we're able to start doing those things for you automatically. In addition to all the virtual and physical relationships that we show you in the ACI console, and in addition to the ACI health scores that we show you as reported by the environment, we also give you the basic hardware information about the environment as well. And by basic, I just mean simply that it comes from SNMP. We treat those just like we would any other hardware device, and they provide back that same hardware type information. So for example, memory utilization, CPU utilization, interface utilization, things like that. So that is provided as well in addition to the ACI console and the ACI health scores. So you can see that information here on this screen for each of the components within the environment. You can also see these out-of-box dashboards are right here. So under ACI reporting, we have the ACI console, ACI health, and again, the switches overview, which is what we're looking at right here. This all comes right out of the box. So once you've connected into the APIC and we have the information and start gathering it, all of this information is available to you as soon as we've contacted those devices. So today we talked about what goes into a modern network performance monitoring and diagnostic tool. Uh, First thing that we talked about was scalability, extremely important in new software-defined environments, as inventories can be very elastic and to scale up to meet demands and then shrink back down. So the ability to be able to monitor these large environments, whether they're physical devices or virtual devices or virtual constructs, is extremely important. One of the other things that we talked about was the ability to have advanced visualizations of these environments that goes cross technology. So instead of having siloed views of the environment, I want to have a horizontal slice that looks across everything that might affect a service or application that I'm providing to my end users. The way we're able to do this with CA's tools is using a base of CA performance management. This product does SNMP, non-SNMP monitoring out of the box. It also has plugins that allow you to do things like flow analysis, application analysis, SDN, SD-WAN type of environments as well. And they all plug into the framework and then are represented in a visualization layer.